Today, safety hazard wise, one of the things we're going to be using is this neodymium magnet, which is a super duper strong magnet. And you want to make sure that you keep this magnet away from metal, any kind of laptop or electronic equipment, and that you keep it away from other magnets. So if another group is using a magnet, keep it far away from the other group. These are so strong. It's really even hard to separate them from each other. To put it near, it's going to snap together really forcefully, and you could snap your finger if there's metal nearby and it tries to attach. If you were to get like two of them to just come together, they're really hard to separate, and it might be really hard to separate from metal if you happen to get it attracted to it. You're going to use these balances, and they should either be already out at your station or in one of your little skinny cabinets nearby your lab table. Turn it on, and again, we want to keep space between this magnet and any metal, including the metal on your balance. So that's where this spacer is going to come into play. We are going to put this on top, and then we are going to put our magnet on top so that it provides space between the metal and our magnet. And honestly, it works best if you have a scale that only goes up to the hundredths place. If you have one that goes beyond that and you get a lot of fluctuation with this part, I'd recommend using another group's balance, waiting for them to be done. What you're gonna do is you're gonna zero this whole setup, and you should get a zero reading. Again, if you get a lot of fluctuation here because you have more decimal places, I would use someone else's setup. And then you're gonna take your vials, record the color in your data table. Be creative about it, what color it is, channel your inner Crayola. And all we're gonna do is we're gonna start seeing if any of these substances are attracted to the magnet. What you try to do is get this vial as close to the magnet as possible without actually touching it. And you're gonna notice, hey, look, for this substance, it's dipping into the negative numbers. What does that mean? That means my magnet is being attracted to this substance, and that's why it's being pulled off of the scale and resulting in a negative mass. Get the most negative value that you see, but not touching because I don't want my fingers or the vial to affect that mass. So you record the most negative number that you see and put it in your data table. Some people like to flip those from negatives to positives to show the force of attraction, but either way is fine. And you just do that for each. Now, obviously, it's not an exact science of how far apart these are, and it might be different each time, which is why I say record the most negative value that you see as you do this. And again, try to get that vial centered on it, but without touching. And you do that for each. And we're going to start ranking the attraction to a magnet of these different substances and start to try to account for the reason by looking at their electron configuration and orbital notation. For safety, again, when you are done, pick up the magnet, put it away from metal as soon as you're done, put everything back into your container when you're done, and bring it up.